LG CloiD is an AI-driven home robot introduced by LG Electronics as part of its vision for a zero-labor home, designed to take care of real household chores by learning your routines, interacting naturally, and coordinating with connected smart appliances. It represents a major step toward bringing physical AI into everyday living spaces and reducing the time and effort families spend on mundane tasks. CloiD rolls around your home on a stable wheeled base that uses autonomous navigation borrowed from LG's robot vacuum technology, letting it move safely through kitchens, laundry rooms, and living areas without tipping over if bumped by a child or a pet. It has a torso with 2 articulated arms, each offering 7 degrees of freedom for lifelike movement, and hands with 5 independently controlled fingers that handle delicate tasks with precision. This dexterity lets CloiD pick up groceries, place items in appliances, fold and stack laundry after washing, and even prepare simple food items in a realistic home demo. MagRail Booster by Nomo is a groundbreaking rail innovation that turns ordinary freight wagons into autonomous, self-propelled cargo carriers using electromagnetic linear motor propulsion, eliminating the need for traditional locomotives and delivering a smarter, greener way to move freight on existing rail lines. It is the first retrofit system of its kind designed to integrate directly with current railway infrastructure while boosting flexibility, efficiency, and capacity. The core of MagRail Booster is a high-efficiency electromagnetic linear motor that supplies direct drive and braking force to each equipped wagon. Power electronics feed the linear motor technology, while a command and control system manages movement, safety, and coordination with rail operators. This blend of electrification and automation lets wagons operate either independently or in coordinated formations, adjusting to demand with precision and stability. MagRail Booster can run on unmodified standard tracks at speeds up to about 100 miles per hour, making it competitive with modern freight operations without requiring new lines or catenary systems. Retrofits include advanced communication systems and autonomous connection and disconnection capability, which together let wagons join or leave sets automatically as needed. The system is engineered to cut direct emissions by shifting from diesel-powered locomotives to zero-emission electric propulsion, advancing sustainable freight movement while maintaining compatibility with current safety and operational standards. Oceanbird Orcelle Wind is a revolutionary wind-powered roll-on jogged roll-off cargo vessel designed to slash emissions for heavy freight shipping by harnessing clean wind energy through giant rigid wing sails and advanced hull design. Developed by Wallenius Marine in collaboration with industry and research partners, Orcelle Wind reimagines how deep sea transport can reduce environmental impact while still carrying large loads across ocean routes. This next-generation ro-ro ship measures about 720 feet long and 130 feet wide, with enough deck space to carry more than 7,000 vehicles along with heavy and break-bulk cargo, helping logistics operations shift from traditional diesel fuel to wind propulsion as the primary energy source. Orcelle Wind's standout feature is its 6 massive 40-meter-high aerodynamic wing sails, engineered from high-strength composites and recyclable materials. These rigid wings operate more like aircraft wings than traditional canvas sails, rotating and tilting to capture wind from any direction and fold down to clear bridges or navigate ports safely. Under wind power alone, the vessel targets an average crossing speed in the 12-mile-per-hour range, delivering significant propulsion while dramatically cutting fuel use. Combined with its unique aerodynamic profile and optimized hull, Orcelle Wind aims to reduce carbon emissions by up to 90% compared with a conventional diesel-powered cargo ship, making it one of the most sustainable concepts ever proposed for large-scale maritime freight. Acecore Noa is a heavy-lift professional hexacopter built to tackle demanding aerial missions with endurance, stability, and real payload power. It is engineered around a rugged carbon fiber frame with 6 redundant brushless motors that deliver reliable thrust and stable handling even in challenging winds up to about 29 knots, making it ideal for surveying, industrial inspection, mapping, and high-end cinematography. Noa carries payloads up to 44 pounds, letting operators lift professional cinema cameras, LiDAR scanners, or other mission equipment with confidence. Maximum takeoff weight is about 81 pounds, which gives room for heavy batteries and accessories while still meeting strict performance demands. Depending on configuration and battery choice, the platform can stay airborne for up to 80 minutes, delivering long flight endurance that cuts down on downtime and boosts productivity on big jobs. The aircraft uses quick-release landing gear, toolless boom attachments, and a modular payload interface with standardized connectors so teams can swap gear quickly between flights. Redundant control systems and multiple power options keep flight consistent, with robust weather resistance against moderate wind and precipitation for dependable operation in real-world conditions. Noa's blend of heavy lift capability and long endurance makes it a go-to choice for professionals who need reliable aerial support and mission flexibility without sacrificing performance or safety. Vook E-Trike is a cutting-edge electric three-wheeler designed for long-range travel and everyday mobility with strong power, advanced connectivity, and modern convenience built into a robust, low-riding frame. It uses dual rear hub motors rated at roughly 3,000 watts nominal power with up to 6,000 watts peak output, giving it brisk performance for a vehicle in this class and letting riders tackle mixed roads and open terrain with confidence. The structural frame is made from lightweight yet sturdy 6061 aluminum that balances durability and agility, and the E-Trike sits on puncture-proof tires designed to handle pavement, packed gravel, and light off-road surfaces without constant maintenance. Riders enjoy a full suite of features, including a water-resistant metal LCD display mounted on an adjustable arm, showing speed, distance, battery status, navigation cues, and ride data. Battery options include a long-range 50 amp-hour pack that delivers up to about 110 miles per charge, and a standard 30 amp-hour pack rated up to about 80 miles per charge, depending on riding style and conditions, with a typical recharge time between 2 and 4 hours. The battery also doubles as a 120-watt power bank with multiple USB-A and USB-C outlets to charge devices on the go. Voxon VX2 XL is the world's largest 3D volumetric hologram display, built to bring fully interactive, three-dimensional holograms into real space in a way that feels solid, viewable, and engaging from every angle without glasses or headsets. It's engineered for creative pros, museums, entertainment venues, scientific visualization, and educational environments, where seeing real 3D data in motion makes a difference. At its core, this system uses advanced VLED volumetric display technology that sweeps millions of individual points of light through a cylindrical viewing volume roughly 20.5 inches wide and 10 inches tall, generating up to about 16 million full-color voxels, tiny three-dimensional pixels, to form images that occupy real space and can be seen from 360 degrees around the device. The display renders these holographic volumes in real time while connected to a standard Windows PC running familiar 3D design tools. Unlike flat screens or traditional stereoscopic methods that rely on glasses or head tracking, the VX2 XL's volumetric engine creates imagery that has depth, perspective, and parallax naturally. When an observer walks around it, the holograms shift accordingly just like a real object would. Unlike flat screens or traditional stereoscopic methods that rely on glasses or head tracking, the VX2 volumetric engine creates imagery that has depth, perspective, and parallax naturally. When an observer walks around it, the holograms shift accordingly just like a real object would. Zero Airbus refers to Airbus's ZERO project, the aerospace maker's vision for a world's first zero-emission commercial airliner that runs entirely on hydrogen propulsion and electric power, targeting entry into service around 2035 as part of a broader industry shift to decarbonize flight. Hydrogen powers the aircraft's engines without burning fossil fuel, and the only significant byproduct of the hydrogen fuel cell reaction is water vapor, meaning this aircraft concept aims for truly zero carbon emissions in cruise. Unlike conventional jets that rely on jet fuel combustion, Zero Airbus explores hydrogen as the primary energy source in two key ways. hydrogen combustion in modified turbine engines, and increasingly, hydrogen fuel cells that generate electricity to drive electric propulsion systems. In recent years, Airbus has shifted its focus toward the fuel cell electric pathway because it offers higher potential for emission-free power with the right technology maturity. This approach uses liquid hydrogen carried on board at extremely cold cryogenic temperatures, stored and distributed through advanced systems developed with partners and tested as part of a broader technology roadmap for hydrogen flight. Concept designs in the ZERO family have ranged from a turbofan aircraft capable of carrying roughly 120 to 200 passengers with a range exceeding 2,000 nautical miles to a turboprop variant sized for shorter routes up to about 1,000 nautical miles, as well as a blended wing body configuration offering potential advantages in cabin space and hydrogen storage. Looki L1 is a next-generation multimodal AI wearable designed to see, hear, and understand your daily life, rather than just react to commands, moving the category toward proactive intelligence that anticipates what you might need next. It debuted at CES 2026 as one of the first wearables built to automatically capture meaningful moments, summarize experiences, and offer contextual insights without constant user input. Built for unobtrusive all-day use, the L1 weighs just about 32 grams and delivers up to about 12 hours of battery life in story mode, letting you wear it around your neck, clip it to clothing, or place it in a convenient spot while it monitors daily activity. The device captures high-resolution photos and 1080 pixels video at 30 frames per second, and stores about 32 gigabytes of content locally, so you stay in control of your own data from capture to storage. What sets this wearable apart is its proactive AI engine. Using visual, audio, and motion sensing, Looki L1 recognizes different contexts and automatically switches between adaptive modes, such as Expo mode for events and networking, fitness mode for activity tracking and cues, and everyday life mode for lifestyle and routine insights, without you needing to press a button. It builds an intelligent memory of your day and can automatically generate short highlight reels, daily recaps, and even visual story pages that help turn routine moments into searchable, organized narratives. Radian One is a single stage-to-orbit spaceplane built to launch like an aircraft, hit orbit in one push, and roll back onto a runway without needing a booster rocket or a recovery fleet. It uses a 10,000-foot standard runway for takeoff and a 2-meter ground rail sled that drives it to roughly 537 miles per hour before the main rocket engines come alive. That launch assist cuts fuel load, boosts efficiency, and gives the vehicle a cleaner climb profile. It supports a crew of 5 and carries 5,000 pounds of cargo to low Earth orbit. What makes it even more striking is the return capability of 10,000 pounds, which allows large downmass recovery for research, defense assets, and commercial hardware that normally cannot be brought back intact. The airframe is shaped like a high-performance lifting body, giving strong aerodynamic control during re-entry and a smooth transition to subsonic flight for runway landing. Radian One is engineered for fast cycling. The team targets a 48-hour refurbishment window with on-demand readiness in 90 minutes, which pulls orbital flight into something that feels closer to high-end aviation rather than old-style rocket scheduling. Radian One brings orbital access closer to something familiar, like watching a high-performance aircraft take to the sky and return the same day with work finished. MentorPi is an advanced open-source robotic car platform powered by the Raspberry Pi 5 and fully compatible with Robot Operating System 2, designed for AI and robotics enthusiasts who want to explore real autonomous capabilities like three-dimensional mapping, navigation, and object detection at the edge. It comes with rich hardware and software support that turns a compact mobile base into a complete experimental vehicle for teaching, research, coding, and prototyping intelligent robot applications. This platform offers multiple drivetrain options, including a Mechanim wheel chassis for omnidirectional motion and an Ackerman chassis for car-like steering, letting users choose the locomotion style that best fits their project goals. MentorPi integrates high-speed closed-loop encoder motors with high-torque servos, giving robust, precise locomotion whether you are executing path planning or dynamic obstacle avoidance. Sensors are a core strength of this platform. It includes a 360-degree time-of-flight LiDAR sensor and a 3-dimensional depth camera that together feed environmental data into the robot's simultaneous localization and mapping system, enabling detailed spatial awareness and real-time creation of environment maps. HMND01 Alpha is the United Kingdom's first industrial humanoid robot, built to work fast, move smooth, and handle real factory pressure without slowing down. The frame stands 7 feet 2 inches tall, rolling on a stable wheeled base that reaches speeds up to 4.5 miles per hour. It lifts and carries payloads of 33 pounds with clean, controlled motion, making it a natural fit for warehouse picking lines, sorting tasks, packaging zones, and feeding heavy equipment on production floors. It runs on 29 active degrees of freedom, supported by advanced artificial intelligence motion control, which gives the robot human-level precision when reaching, grabbing, or coordinating multi-step tasks. The developers completed the entire build in 7 months, which places HMND01 Alpha among the fastest fully engineered humanoid robots ever created for industrial use. The structure uses high-strength materials, a reinforced torso, and energy-efficient electric actuators that keep the movements consistent and safe around people. Real-time sensing provides obstacle awareness and responsive balancing, while the adaptive control system allows rapid training for new workflows. Many operational demos confirm stable endurance performance, meaning the robot can run long shifts without overheating or drifting out of calibration.